start our unit on weather with tracking hurricanes. It seems a little early in the unit to be tracking hurricanes, but based on the calendar, it's really the perfect time. September 15th is the peak of hurricane season, and if you take a look at the map from today, September 15th, 2020, we have a lot of activity in the Atlantic Basin. What these symbols are showing you is the tropical cyclones and disturbances that are coming across and potentially could cause damage in the U.S. and Mexico and in the islands. The key, if you have a yellow X, it has a less than 40% chance of developing into anything stronger. Those are usually just storms, and they'll sort of dissipate after a short time. If it's 40 to 60%, and particularly close to the coast of Africa, that means it's got a 40, if it's orange, it's got a 40 to 60% chance of developing into a tropical storm or something larger. You've got two, Teddy and Vicky, they have a circle with little tails. The center of the circle is hollow. That means tropical storm. And there are two in the Atlantic right now. Now, if you come closer to the U.S., we have Sally has a closed-in circle with two tails. That means Sally is a hurricane bearing down on the Gulf states right now. Paulette, another hurricane, is actually going out to sea, so should not cause us any problem. But it's a great time to start tracking. So why do we bother tracking hurricanes? Keeping track of how strong a storm is, the speed it's traveling, and the direction it's traveling is unbelievably important for public safety. Meteorologists, who are scientists, government agencies, have to figure out where and when to evacuate. Evacuate means making people leave their homes. And you want to leave your home if a hurricane is coming right at you. But you don't want to try to evacuate the entire eastern seaboard. Like you wouldn't evacuate people in Maine if there's a hurricane in Florida. You wouldn't really necessarily evacuate people in North Carolina if there's a hurricane hitting Florida. It wouldn't have an effect on them. They're not at any risk. But if there's a storm coming toward North Carolina, you certainly want to get those people out of there. So figuring out where the storm is most likely to hit, super, super important. And we do that, they figure that out by tracking where it's going. Now, the problem with storms, there's so much variability in weather that it really is difficult to give a 100% forecast about any storm in particular. We know in general where it's going, we know in general the strength, we know the conditions that would make a storm get stronger, we know the conditions that would make a storm get weaker, but there are really too many things in play to be able to be 100% sure. We really want as much information as possible because more information is better forecast. Evacuating at the right time and right place reduces the loss of life during a hurricane. When a hurricane's coming, they're not trying to protect your stuff. They're not trying to protect your property, your house, your car. They're not even trying to protect your pets. They're trying to protect you. They're trying to protect your life. And in order to protect your life, they have to give you clear, accurate information about when you need to get away from your home. You do not want to be in the path of a hurricane. This is Katrina. Katrina was a catastrophic storm. As it was coming across the Gulf of Mexico, it actually blew up to a Category 5, which is the strongest category for hurricane. It dipped slightly to a Category 4 right before it hit the coast. It caused unimaginable damage in the states of Louisiana, Mississippi, and Alabama. Just unbelievable damage. Entire sections of those states were destroyed completely, buildings completely washed away. In other sections, the low-lying areas were under 20 feet of water. Many people left, many people tried to leave too late. And so there was a lot of lives lost, and there was an unbelievable amount of property damage. By the time some people tried to leave, there simply was no escape path. So when you get an evacuation warning, it's really important that you listen, even though it does cost a lot of money to evacuate, it takes a lot of time, it's a lot of effort, it's your life you're playing with. So once you've been told you should evacuate, it's really a good idea to go. There will be times when you evacuate and your area is not hit. And then people get frustrated and say, forget it, I'm not going next time. It's always a good idea to evacuate when you're asked to. Now, Hurricane Sandy, which is the first one we're actually going to track, and the reason we're going to track it is because it has something to do with us, and it's a very easy storm to track. It didn't last for a very long time, and it followed a nice path so that on a tracking map it's super easy to track. So, and it was also a very interesting storm because Sandy, which had gotten all the way up to a Category 3, had actually pretty much diminished. It got to a point where the National Weather Service wasn't even following it anymore because it was gone offshore. The expectation that it wasn't going to do any damage. Unfortunately, it joined with a nor'easter that was forming and then got pushed back pretty much into New York Harbor at high tide. So the damage, here's an example from New Jersey. It was extreme, but not nearly what Sandy, Katrina, the Category 5 had done. So you can see that there's a lot of damage here, but it's not nearly what a larger storm would have done. So when you're tracking, the first thing that you need is actually a data set. And when you click in the presentation, it's going to bring you to the data set for Sandy. And there is another piece of information that you're going to need, which is a tracking map. And this is the tracking map that is provided by NOAA. Now, the board is just not cooperating, so I'm going to go old school and do it on paper and pencil and show you how to do this. We will do tracking when you're in class, but I want to give you a preview of the process on the videotape before we're together, so you'll start to get an idea of how it's done before you have a map and a pencil in your hand. My smartboard absolutely does not want to be cooperative. So we're going to go old school, and we're going to do it on a paper tracking map, which is fun. So here's a NOAA tracking chart for the Atlantic. You'll notice, if I zoom in and take a look at the grid on the edge, it's just a coordinate point graph. Far corner, you've got 10, 15, 20 going across. You've got 40, 45, 50. If you take a look at the other corner, you're going 10, 15, 20 again, but now you've gotten all the way out to 100 degrees longitude. So the section of the map that we're going to focus on is this section right in the center, because that's where most of the path that Sandy followed was. So our storm started out at 17.5, 78. So we're going to head to the 78 latitude, 78 longitude, which here's 80. This dark line is 80, and this dark line is 75. So I need 78. So I've got 75, 76, 77, 78. And the latitude is 13.5. So we've got the 10 and the 15. So we're going to go 10, 11, 12, 13, 78. So it's going to end up being right here. We're going to draw a circle because the symbol for storms, once they've reached tropical storm, is a circle, and if it's a tropical storm, the circle's hollow, and if it's a hurricane, the circle is colored in. It's a tropical storm at this point, so we're going to darken it a little bit, put little tails, and then we have tropical storm Sandy making an appearance on the map. And then we're going to cross off on our data sheet because we don't want to do the same one again. So now we're going to have 77.8, that's the next one. So 75, 76, 77. It's not quite 78, it's 77.8, and then 13.8. So it's actually very close to that last dot. And trying to do this so that you can see it. My dots are getting a little bit bigger than I normally would put them. No worries at all. and then we're going to cross that one off. So as you're going down the data table, once you've marked it, you're going to cross it off so you don't make a mistake. Then you want 76.7, so we go back to our 75, 76.7, a little more than half, 17.1. So there's 15, 16, 17.1. So it's right about here. And at this point, when it's bearing down on Jamaica, it is a hurricane. So we fill in the dot and put the tails. And when it hit Jamaica, it was a Category 1 hurricane. Storms tend to slow down a little bit when they hit land. Unfortunately, it was over warm water, so as soon as it finished causing damage in Jamaica, it actually picked up a little speed and got up to a Category 3. And then it went to 22.4, which is about halfway, and then 75.5. So we had our storm 75.5, 22.4, it's right about in here. And again, it is a hurricane at this point. So it has gone over, caused problems in Jamaica, it's caused problems in Cuba, it's caused problems in Haiti, but not quite as serious. When it goes directly over land, it really causes a lot more aggravation, a lot more problems, a lot more damage. So now we're going to go to 26.7. So it's moving faster now. You'll notice down here it was moving very slowly. Over the course of 24 hours, it moved very little. Now, over the course of 24-hour periods, chunks of time, it's actually moving quite a bit. So we've got 26.7, there's 25, 26, it's almost to the 27 line, and then 76.9. So now we're causing grief and damage throughout the chain of islands. Our next step, again, 24 hours later, is 29.76. Still a hurricane. And then we're going to jump to 32.5. So there's 30, 1, 2, midway. But now it's 72. So it actually, at this point, it was 72.6. It's actually appears to be going out to sea. So let's join these dots to make that a little clearer. And when you join the dots, even though when you see it on the news, it's often a nice curvy line, we use a straight line, we use a straight edge, we use a ruler to mark our path. And it allows them to figure out where the storm should be going next. And once you put those dots together, it makes a much clearer path. And at that point, it actually looked like the storm was pretty much headed out to sea, and they were much less concerned about it. And so then it took another jump at the next reading, 37.5, 71.5. So it was right about here. Again, it was a hurricane. But at that point, it was barely a hurricane. It was getting over colder water. The expectation was that it would diminish. And that was the last time the National Weather Service actually sent spotters out to determine the location of Sandy.